This is part 2 of the homework video guide for section 1.4, and we're going to start this video guide with question 4b. And for question number 4 in general, you're given these two statements. The square root of 21 is roughly 4.58, and the square root of 210 is roughly 14.49. And I need to determine the value of the square root of 0.21. Okay, so just like the previous questions, you need to decide which statement you would like to use for this problem, the blue one or the green one. All right, so let's figure that out. Since we have just count the decimal places. Here's 1, here's 2. So we have 2 decimal places, right, for 0.21. So since 2 is an even number, you're better off using this approximation here because the square root of 21, there's 2 numbers there, 2 and 1, so that's an even number. So let's use the square root of 21 to help solve this particular problem. Okay, so we're going to use this statement here. And then let's just rewrite 0.21 into a fraction. So this is going to be 21 divided by 100. Okay, so we're using 21, right? So we need to have 21 in our numerator. And how do I change 21 back into 0.21? Well, since there's 2 decimal places, we can have 2 zeros there, right? So 0.21 is the same thing as 21%. And that's the same thing as 21 over 100. Okay, so now we need to find the square root of 0.21. So let's take the square root of that. And this is the same thing as the square root of 21 divided by the square root of 100. Okay, the square root of 100 is going to be 10, and we can use this statement now for the square root of 21, which is 4.58. And since we're dividing by 10 here, you just move the decimal spot 1 spot over, right? So this will be 0.458 as a final answer for question 4b. Okay. Let's move on to question 4f. And for 4f, I had the square root of 0.0021. So how many decimal places is that? That's 1, 2, 3, and 4. So there's 4 decimal places. And 4 is an even number. So you have to decide which statement you like to use for this problem here, the blue one or the green one. Well, since there's 2 numbers here, the square root of 21, there's 2 numbers inside. That's an even number. So we want to use this expression right here. Okay, and after that, we're going to take 0.0021, and I want to write that as a fraction. So since I'm using the square root of 21, let's go ahead and take this 21 and let's put that on the numerator. And then we want to change 21 back into 0.0021. So since you have 4 decimal places here, you better have 4 zeros. And then let's put a 1 there. Okay. So 21 divided by 10,000 is 0.0021. All right, now the question is, I want the square root of this. So let's take the square root of that now. And this is going to be the square root of 21 divided by the square root of 10,000. Okay. Now the square root of 10,000, that's going to be 100. And the square root of 21 is going to be 4.58 roughly. And when we're dividing by 100 here, since there's 2 zeros there, we want to move the decimal spot 2 spots over, so 1, 2. So our final answer will be 0.0458. Okay, so that's it for question 4F. I thought all the questions, actually we still have a few more questions to go, but a lot of the questions on 4F are quite challenging, so make sure you kind of do these questions a second time if you like. Okay, let's go to question 4C now. I want to take the square root of some of these bigger numbers here. Okay, so I see 21 there, so let's rewrite this as, 21 as 21 times, and then I have 2 zeros there, so that's going to be 100. All right, so 21 times 100 is 2,100. And then I can break this up into individual square roots, so that's going to be the square root of 21 times the square root of 100. I know the square root of 100 is 10, and I know that the square root of 21, if I go back to the original problem here, that's going to be 4.58. Okay, If I multiply by 10 here, you just move the decimal spot. So 4.58 times 10, the number is getting bigger. And since you have 1 0 there, you just move the decimal spot over. So that gives you 45.8 as a final answer for that one. Okay, let's move on to letter E now. Okay, so what I see now is, well, I know 21. Let me just rewrite the number here. 21 and 0, 0, 0, 21,000. That's the same thing as 210. And then these two zeros here, I'm going to multiply by 100. Okay. So 210, which is this part in green, is that part in green right there. And then I'm going to multiply that by 100. And that gives me the same number, right? So the square root of that is the same thing as the square root of that. And then the square root of 200, I can break this up into the square root of 210 times the square root of 100. Okay, and I know the square root of 100 here is going to be 10. And I know the square root of 210 is roughly 14.49. And if we're multiplying by 10, here, the number is getting bigger, so you just move the decimal spot one spot over. So 144.9 would be your final answer for that one. Okay, so that's it for question number 4. Let's move on to some of these other estimating problems. Question number 6. I want to estimate the value of the square root of 11. Okay, so this one's not too bad. You need to think about some other values that you might know the square roots of. So for example, let's just put square root of 11 here in the middle here. And I know that the square root of, let's see, do you know the square root of 9? I sure do. And do you know the square root of 16? I sure do. So what we're going to do is we're going to force the square root of 11 in between two other square roots where we do know the answer. I know the square root of 9 is going to be 3, and I know the square root of 16 is going to be 4. That means the square root of 11 is going to be between 3 and 4. So since 11 is closer to a 9 than it is to a 16, we can approximate this to be roughly, I don't know, 3.2. So, I mean, that could be a decent approximation, 3.2 or 3.3. Those are all pretty close approximations, but you shouldn't say like an answer like 3.9 or 3.7. So 3.3 is roughly around here. Or let's just write down the square root of 11 is roughly in that region right there. And that's all we're going to do to estimate these square roots. Okay, let's move on to the next one, the square root of 29. Okay, so the square root of 29, I have no idea what that is, but we're going to force that into two other square roots where we do know the answers. So I know the square root of 25, and I know the square root of 36. Okay, I know the square root of 25 is going to be 5, and I know the square root of 36 is going to be 6. That means the square root of 29 is between 5 and 6. So since 29 is closer to the 5 than it is close to the 36, so 29 is much closer to 25 than it is 36, it should be closer to like, I don't know, maybe 5.3 again. So 5.3, 5.4 maybe, but you shouldn't say it's 5.9. So I would say somewhere around here is where the square root of 29 will be roughly. And that's all we're doing for these kind of problems. We're just estimating here. Okay, let's go to the next one, the cube root of 100. So the cube root of 100. All right, so we're going to force that into some other cube roots where we do know the answer to. So we know what cube root of 64 is. And I definitely know what the cube root of 125 is. Okay, so we're gonna force the cube root of 100 between two cube roots where we do know the answers. So the cube root of 64 is going to be 4, and the cube root of 125 is going to be 5. So that means the cube root of 100 is going to be between 4 and 5. Now I think 100 is closer to 125 than it is 64, so it's going to be over 4.5, right? So if we kind of think about this number, we can think about it as maybe 4.6 or 4.7. Those are all good approximations for the cube root of 100. So I would say somewhere around here, this is going to be the cube root of 100. All right, so that's a very good approximation for that particular question. Okay, let's move on to a few more approximations here. 2 more approximations, and then we'll finish off this homework video guide. Okay, so another similar example, how do I approximate the cube root of 30? So let's put the cube root of 30 in between two square roots. Sorry, I need to approximate the square root of 30, and what we'll do is we'll force the square root of 30 into two square roots where we do know the answers to. So I'm thinking of the square root of 25 and the square root of 36. So the square root of 25 is going to be 5, and the square root of 36 is going to be 6. So that means the square root of 30 is going to be in between 5 and 6. All right, so it's pretty close. It's still closer to, I would say it's closer to the 25 than it is to the 36, right? So I'm thinking it could be maybe 5.4, maybe 5.45. It's very close, right? So as long as you're kind of close to 5.4 or 5.5, then that's good enough. So let's just say approximately, 5.45, just to be safe. Okay, so that's a close approximation there. All right, and finally, the last one I have negative root 58. Okay, so let's force that into two other square roots where I do know the answers to. So I know the answer to the square root of 64, and I know the answer to the square root of 49, right? Okay, so we're going to force the root 58 into something that we do know the answer of. Okay, so we know the square root of negative 49 is going to be negative 7, and this is going to be negative 8. So what that means is the square root of, negative square root 58 is going to be between negative 7 and negative 8. Okay, so the 58 is a little bit closer to the 64 than it is to the 49. So it's going to be a little bit more towards the 8 than it is the 7. So I'm thinking about negative 7 point, more than 5, right? So maybe a 6. Negative 7.6 is pretty good. And that's a very good approximation to this particular problem here. Okay, so once again, the last few questions, we're just approximating the square root of some of these irrational numbers, and I would force that square root into other square roots where you do know the answers to, and then just approximate. All right, so that's it for this homework video guide.